In this session, we will learn about what are the topics that we will cover in this session. We'll learn about the definition of the dummy variable trap. We'll learn about the scenario how dummy variable trap is generated. Then we'll learn about mathematical reasoning behind dummy variable trap, and also we'll solve a linear regression problem involving dummy variable trap issue. So first of all, the definition of dummy variable trap, it is like a dummy variable trap is a scenario in which independent variables are multicollinear. Multicollinearity is a scenario in which two or more variables are highly correlated among themselves. Also, multicollinearity refers to predictors that are correlated with each predictor. Multicollinearity occurs when your model includes multiple factors that are correlated not just to your response variable but also to each other. In other words, it results when you have factors that are a bit redundant. Please note I have highlighted the word redundant because that plays a big role in multicollinearity and as a result in our dummy variable trap scenario. So suppose we have a data set with three columns: intercept, weekdays and gender, and this data set is transformed to dummy columns. As we can see on the right, it is now after the transformation it has 7 rows and 10 columns. Okay. Now, in order to check whether the above data set will have dummy variable trap scenario or not, we will execute the following step. We can already see that our current data set has 7 rows and 10 columns. Then we'll get a transpose of x, which x transpose, and then xt is how it is denoted. Then we'll calculate the vector dot product of x transpose and x, and it will be like X.T.dot.x using Python numpy. And also please note, when we are calculating a dot product, x transpose should come first. Otherwise, if you take x first, then the result will be different or incorrect. We have to ensure the shape of the matrix, which is like x transpose and x will be a squared matrix. It will not be a non-squared matrix because we cannot calculate a determinant of a non-squared matrix, because in a dummy variable scenario the determinant of a x transpose x will play a big role. So if the determinant of x transpose x is 0, then we have hit the dummy variable trap scenario in our data set. Alternatively, what you can say, if you observe that two columns of a matrix is identical, then the value of that determinant will be 0, and hence we cannot calculate the inverse of x transpose x or x transpose x whole inverse. And this means that we have hit the dummy variable trap scenario. If anybody is interested, you can ping me. I have already created a Python function that we will provide the data set, and it will show whether this dummy variable trap scenario or not. So first of all, what we'll do, I have this data set where I have 10 rows and 7 columns. Okay, and after the transpose of this 7 rows and 10 columns, and when we get the dot product of this x transpose x, we are left with what I've shown in the last figure of this. Now our dimension of our data set will be 10 into 10, 10 rows and 10 columns. What we'll do in determinant, if we want to calculate the determinant of a certain matrix, what we'll do, we will apply columns and rows transformation. So what I have applied here, column 0 is equal to column 0 plus column 1 plus column 2 plus column 3 plus column 4 plus column 5 plus column 6. And you can see after this column transformation, my 0th column is exactly like my 9th column, which is my intercept 1 1 1 1 1 3 4 7, right? So the moment it happens, after this we can see like the alternative solution here. Okay, what I've said, if two columns of matrix is identical, then that value of that determinant will be 0. So after that, what we'll do, we'll apply a column transformation again, and we'll say the column 0 is equal to column 0 minus column 9, which will result in the column 1, 0th column, the elements of the 0th column will be 0. And since one of the entire column is 0, so the determinant is 0, hence it is a singular matrix. Singular matrix means the determinant of that matrix will is 0. So this is how dummy variable trap scenario is generated. Till now we have learned this. Now we will learn what is the solution for dummy variable trap. The solution to dummy variable trap is to drop one of the categorical variables, or alternately drop the intercept constant. If there are p number of categories, use p minus 1 in the model. The value left out can be thought of as a reference value, and the fit value of the remaining categories represent a change from this reference. The dummy variable trap can be solved by dropping one of the categorical variables. We can also drop the intercept. There are two solutions. Either you drop one of the variables on the categorical column, or you drop the intercept. Now, suppose if there are a p number of categories, then we can use p minus 1 in the regression model. The remaining values can be thought of as a reference value and fit the remaining categories that represent the change from this reference. Now, I have already shown in my previous example, like not shown till I have covered half of that. Like if all the 7 days are included, there is a multicollinearity. See, it's a perfect multicollinearity because we can get like from here. Ultimately, what happens? My intercept will be equal to my this value, this column. Okay. Similarly, we can apply like if you consider gender column as dummy, then we can so p minus 1 like 2 minus 1 which is equals to 1. So we'll consider one column only. And in case of week days of the week, we'll consider 6 columns. 7 minus 1 6. Now let's do some experiment which will clear our thought about the dummy variable trap scenario. What I have done, I've created a small matrix wherein we will do the different permutation and combination and check how this dummy variable trap scenario is generated and how to handle the dummy variable trap scenario. Okay, what we will do, I have an expense data set. Okay, if you go to my variable explorer, I have expense data set which has 4 columns, 5 column. Last column is my output column. So intercept, weekdays, gender and age is my column, and like last column is showing we need to predict this how much expenses. So what we will do, we will follow simultaneously our metrics and we will one by one will execute this. So first step says we will include the intercept column, we will include the weekdays column, and we will drop the gender column, and we'll consider the age when we will be calculating we will be implementing the solution for linear regression. Case 1, intercept. What we'll do, df1, well, df1 is equals to pd.getDummy. pd.getDummies I've already explained in my several videos. In my last videos, I've already explained in details about the difference between one-hot encoding and the dummy encoding. And this, I'll include the link in my description. We will transfer this weekdays. So if you see weekdays here, it will be like from Friday, Monday, so all the days of the week are covered here. After that, we will create our feature variable x, which is equal to pd.concat, and then we will include our df1, which is our weekdays dummy column for the weekdays, and the intercept that as per my metric, and then we'll give axis because we are concatenating them horizontally, like two columns are being parallelly concatenated. Feature vector is created. Okay, Friday from Friday, everything followed by the intercept. The most important thing, why I have been like from like past 15-20 minutes, I have been emphasizing more on x x, like x.t, which is the x transpose dot x, which will be like this. I will be coming this in a while, but there is something called we need the formula to compute the beta vector. Okay, which will be I'll be coming in, but I just want to show you this x transpose x whole inverse. So we will not calculate all those things, just we will calculate now, and just we will calculate np dot linear dot not solve dot inverse. Even you can calculate np dot. What is our main target here? Main target is to get the whether the determinant has a value or not. So if the determinant has a value, then only we will be able to calculate the inverse. So let's execute this. Okay, so we have this. It will not be calculated because it has hit the scenario. Okay, and moreover, if you see the determinant value we cannot calculate. Okay, because the determinant value itself is 0. So that's what I am trying to explain. Okay, now let's see the other scenario. The other scenario is to include the intercept, include the dummy, include weekdays by applying dummy encoding, and will not include the gender. So simple. Here we will include intercept, like we will include the weekdays by using drop first is equal to true. Now the moment we include drop first is equal to true, and then we will try to calculate a determinant. We have some values for the determinant. Also, if you try to calculate this x dot this vector, like if you want to do some permutation and combination with the column transformation, you will not end up getting two columns same. That's why the value of determinant is there, it is not 0. Now let's see the third case in our matrix, which is to include the intercept, include the weekdays by applying one-hot encoding, and include the gender by including one-hot encoding. Simple. Now what we will do, we will apply one-hot encoding on both gender as well as weekdays. So okay, one more thing, we should not give drop. It's a case of one-hot encoding, not dummy encoding. So again, till here we'll execute. Now if you want, if you can see here, like if you add this all the column weekdays column, will end up getting 2 2 1 2 2 2 2 5 10, like 2 plus 1 3 4 5. Even for Fridays also, like the last row also, it will become the same. Now again, leave the weekdays. If you add the male and female column also, you will end up getting the intercept. So that's why it is not dependent on one cat. It is dependent on all the categorical columns which you have. So that's why either you remove the intercept column or you remove the one column from each category. So in this case, we can see that we have two columns which will become same. So the determinant will again be 0. So if you print this, it will be 0. And now if you want to try to calculate this, it is a case of singular matrix which has a determinant 0. So which is absolutely correct. Now we will see the fourth case, wherein, what is our fourth case? Fourth case is include the intercept and include weekdays and gender by applying the dummy encoding. So in this case, we will not hit the dummy variable trap scenario because we are already deleting that column for one column from each categories. Now we'll do drop first is equals to true, and then we'll calculate this matrix. So you go x transpose x, and now if you want to like check for weekdays also, and for Monday, Saturday, Sunday also, you cannot add and get the intercept column. Okay, so that is the reason. Now if you want to calculate here, the determinant will have some value. It has some value, and so it will be inverse will also be calculated successfully or correctly. Four scenarios we have got. As per the other case, what we can do, we can either remove one column from each categorical column, or we can remove the intercept column. Now we will do that. Our step 5 and 6 will be related to that. Drop the intercept and include weekdays and gender by using one hot encoding. This will be df1. Now if we calculate here, now if you want to calculate this, see, we don't have intercept column. Now if you add this gender, male and female, okay, you will end up getting the same value we have intercept. And similarly, if you add all the columns, you will end up getting the same value what we have intercept. And still we will end up like getting two columns which has similar values. Like if you add 2 plus 0, first row will be 2 2 2 2 1, like it will be 2 2 2 1 1 1 5 and 5. Similarly, for Friday till Wednesday, like all the values will be same, and still we will get the singular matrix or the determinant will be 0. So if you calculate this, determinant is 0 and it will be a singular matrix case. Now the final case. Now how to handle this scenario? So even in this case also, so how do we handle this case? We will simply will drop first, use drop first. Okay, so here we will see we have already successfully executed all the top 5 rows. Now in the 6th row we will drop the intercept and we will include both the weekdays and gender, because in 5th case we are getting error of a singular matrix. So in order to avoid that, what we'll do, we'll apply drop first or the dummy encoding, and as a result of which, out of the 7 columns from the week, one column will be dropped, and out of 2 columns of the gender, one column will be dropped. So that is what we will apply now. So we have some value for our, and it will not a case of dummy. It's not a case of dummy variable trap scenario. Okay. So this is how we will handle the different scenarios of dummy variable trap. Now let us execute one linear regression problem. So as we know, we have our data set which has 4 columns and one is the output column. Okay. Now we executed this, and we have one column in our data set which is like continuous. When we will use the min max scaler, we will scale it in a range of 0 and 1. So if you open this, we can see all the values of my age is between 0 and 1. You can alternatively go to you can use inverse transform to go back to the original value. We will df underscore will apply the dummy encoding. First we will not apply drop first, and we will see what will be the value. Okay, and x is equals to age and followed by df intercept. Okay, this is my fault. what we'll do, df my age column will be added, the transform age column will be added to my data set. Okay, the transform age column is already added. After this, we will get the our feature variable. So in my feature variable, I have not dropped any column, and I have weekdays, gender, age, and intercept. Now, what we will do, we need to calculate before this, like we'll stop till here, and now I'll go to the mathematical explanation of solution for dummy variable trap is done. Now, mathematics behind a dummy variable trap, like in a multiple regression problem, we want to create a function that we can map the input data into outcome values. Like each data point is a feature vector, x1, x2, x3, dotted xn, and composed of two or more data values. Like we will have whatever I've created there, x is my input variable and y is my output variable. Now, in a simple least square regression scenario, which is a matrix for evaluating the accuracy of my regression problem, we seek a vector beta such that a product x into beta most closely approximate the output vector y. Now, once we have constructed a beta vector, we can use it to map input data to a predicted outcomes, and we can compute a predicted value like y hat is my, when we calculate a predicted value, we call it as y hat. That's why I have given a triangular hat for y hat, and then we calculate it as x dot beta. And the formula to compute the beta vector is x transpose x whole inverse, which I have shown in my whatever experiment which we have done, followed by one more dot product with x transpose y. So now this is the only part which will is left in our linear regression problem. Okay. So the formula to compute the beta vector is beta is equal to x transpose x whole inverse in x transpose y. And in Python, we calculate the above expression as follows. We'll import a numpy and np.linalg.algebra.solve, and we'll get this product is, this expression is calculated as follows. And where we see x dot t is the transpose as x, and a dot b is the dot product of the vector a and b. Now, this I have already explained. The problem which we are doing is related to daily online shopping expenses of male and female in a certain region on a daily basis, and the data set that we are using is just to exploit the scenarios for dummy variable trap. So now we'll come here, and as we have seen, we need to calculate a vector beta. Okay, so beta will be calculated. Beta is equals to np.linear dot and x transpose y also singular matrix, right? Because we have not removed any column, and due to which this error is coming. So what we'll do, we'll simply go here when we are doing get dummies, and we'll get drop underscore first is equal to true. Now if we calculate this beta is calculated correctly. Now as per that, as per the presentation what I have shown, we need to calculate a beta, and y hat is nothing the dot product of x and beta. Okay, so y hat is equals to the dot product of x and beta, x dot beta. So y hat is my predicted outcome. This is what I have predicted. Now I'll create a data set, and then we'll see the difference between the, I'll create a difference between the actual value and the predicted value. Comparison is equals to data frame, and what we'll do, value which is my y, which is my y hat, my predicted value is my y hat. Okay, and then what I will do, I'll simply print comparison data set. Now we will execute. So that's it. This is my actual value, and for some it is matching, and for some it is not matching. It is just for the explanation purpose, and the number of records are very less. So this is how we will. So this is how we can solve the dummy variable trap scenario. In this session, we have learned about the definition of dummy variable trap, how to generate the dummy variable trap scenario, the mathematical reasoning behind dummy variable trap, and also to solve the linear regression. So that's it for the session. So please note, you can contact me at technologycult@gmail.com, and my like GitHub account link is the https://github.com/technologycult. So thanks a lot for watching this session. If you feel this video is helpful, please press the like button, subscribe to this channel, and I'll see you in my next video, which is related to limiting the number of columns or the number of dimensions of a data set. So thank you.